There is enough DNA in an average person's body to stretch from the Sun to Pluto and back. 17 times. The human genome, the genetic code in each human cell, contains 23 DNA molecules, each containing from 500,000 to 2.5 million nucleotide pairs. DNA molecules of this size are 1.7 to 8.5 centimeters long when uncoiled, or about 5 centimeters on average. There are about 37 trillion cells in the human body, and if you'd uncoil all of the DNA encased in each cell and put them end to end, then these would sum to a total length of 2 times 10 14 meters, or enough for 17 Pluto round trips. The average human body carries 10 times more bacterial cells than human cells. It's funny how we compulsively wash our hands, spray our countertops and grimace when someone sneezes near us. In fact, we do everything we can to avoid unnecessary encounters with the germ world. The truth of the matter is that each and every one of us is a walking petri dish. All the bacteria living inside you would fill a half-gallon jug, or 10 times more bacterial cells in your body than human cells, according to Caroline Bohawk, a microbiologist at the University of Idaho. Don't worry, though, most of these bacteria are helpful. In fact, we couldn't survive without them. It can take a photon 40,000 years to travel from the core of the Sun to its surface, but only 8 minutes to travel the rest of the way to Earth. A photon travels, on average, a particular distance, d, before being briefly absorbed and released by an atom, which scatters it in a new random direction. From the core to the Sun's surface, 696,000 kilometers, where it can escape into space, a photon needs to make a huge number of drunken jumps. The calculation is a little tricky, but the conclusion is that a photon takes between many thousands and many millions of years to drunkenly wander to the surface of the Sun. In a way, the light that reaches us today is energy produced maybe millions of years ago. Amazing. At over 2,000 kilometers long, the Great Barrier Reef is the largest living structure on Earth. Coral reefs consist of huge numbers of individual coral polyps, soft-bodied, invertebrate animals, linked by tissue. The Great Barrier Reef is an interlinked system of about 3,000 reefs and 900 coral islands, divided by narrow passages, just beneath the surface of the Coral Sea. Spanning more than 2,000 kilometers and covering an area of some 350,000 square kilometers, it is the largest living structure on Earth and the only one visible from space. But this fragile coral colony is beginning to crumble, battered by the effects of climate change, pollution and man-made disasters. There are 8 times as many atoms in a teaspoonful of water as there are teaspoonfuls of water in the Atlantic Ocean. A teaspoon of water, about 5 milliliters, contains 2 times 10^23 water molecules, but each water molecule is comprised of 3 atoms, 2 hydrogen and 1 oxygen. Moreover, if you laid down end to end each water molecule from a teaspoonful, you'd end up with a length of 50 billion km, or 10 times the width of our solar system. The average person walks the equivalent of 5 times around the world in a lifetime. The average moderately active person takes around 7,500 steps a day. If you maintain that daily average and live until 80 years of age, you'll have walked about 216,262,500 steps in your lifetime. Doing the math, the average person with the average stride living until 80 will walk a distance of around 110,000 miles, which is the equivalent of walking about 5 times around the Earth, right on the equator. When helium is cooled to almost absolute zero, -460 degrees Fahrenheit or -273 degrees Celsius, the lowest temperature possible, it becomes a liquid with surprising properties. It flows against gravity and will start running up and over the lip of a glass container. We all know helium as a gas for blowing up balloons and making people talk like chipmunks. But what most people don't know is that it comes in two distinct liquid states, one of which is borderline creepy when helium is just a few degrees below its boiling point of -452 degrees Fahrenheit, -269 degrees Celsius. It will suddenly be able to do things that other fluids can't, like dribble through molecule-thin cracks, climb up and over the sides of a dish, and remain motionless when its container is spun. No longer a mere liquid, the helium has become a superfluid, a liquid that flows without friction. If Betelgeuse would explode transiting from the red supergiant stage to supernova, then our sky would light continuously for 2 months. It can happen anytime, within a couple of thousand years, tomorrow or even now. Betelgeuse lies some 430 light-years from Earth, yet it's already one of the brightest stars in Earth's sky. The reason is that Betelgeuse is a supergiant star, the largest kind of stars in the universe. Betelgeuse has a luminosity about 10,000 times that of the Sun, and its radius is calculated to be about 370 times that of the Sun. If it were positioned at the center of our Sun, its radius would extend out past the radius of Mars. Because it's near the end of its lifetime, Betelgeuse is likely to explode into a supernova. The known universe is made up of 50 billion galaxies. There are between 100 billion and 1,000 billion stars in a normal galaxy. In the Milky Way alone there might be as many 100 million planets. Still think you're alone? An individual blood cell takes about 60 seconds to make a complete circuit of the body. You have about 5 liters of blood in your body, at least most people do, and the average heart pumps about 70 milliliters of blood out with each beat. Also, a healthy heart beats around 70 times a minute. So, if you multiply the amount of blood that the heart can pump by the number of beats in a minute, you actually get about 4.9 liters of blood, which is almost your whole body's worth of blood. In just a minute, the heart pumps the entire blood volume around your body. If you like this video, click subscribe to get our newest videos. Thanks.